Hi, this is Carlos Zacarias, Sales Manager for PROMAX,
Hello, this is Xavier Ventura.
and we are inaugurating today the interactive virtual show. As you are probably very well aware, the spread of the coronavirus is making it more and more difficult for all of us to reach out to each other, to physically meet each other. So we thought this would be a good opportunity to at least try to bring the show to you and show you what's new in PROMAX, the new developments that we have been releasing lately. Um,
This doesn't mean, Carlos, that we are not going to attend the shows if they happen.
Not at all.
Please stay tuned. Check our website regularly for the latest updates on the show dates. Some shows have been postponed, some have been cancelled, but we try to keep the information on the website up to date. Let's get started.
Yes,
So,
yes.
If you allow me, I will go behind the scenes to man the chat if you have questions or anything to forward them to over to
Yes,
Carlos.
we have a couple of. We want to keep this interactive, so we have a couple of communication channels open for you to send your questions, your comments. One is the chat box that you will find in the lower part of the YouTube screen. In order to use that, you will need to be logged into YouTube. So if you didn't do that already, please do it now. And a second communication channel will be through our WhatsApp number that you will see the number now in the lower part of the screen popping up. You can use both, and please do send us your comments and questions, and we will be replying them at the very end of this session. The idea, as I told you, is to try to introduce to you the Ranger Neo meters and the new developments for them. The Ranger Neos are, as you know, spectrum analyzers that is specifically designed to measure almost any kind of signal that you can find in a broadcast environment. So that means terrestrial links, satellite, terrestrial links like DVB-T, DVB-T2, analog TV, FM, satellite links, DVB-S, S2, S2 multi-stream coming from Earth stations, teleports, SNG tracks, OB bands, VSAT terminals, SATCOMs, etc., etc. You can test as well cable TV signals, IPTV multicast, Wi-Fi, transport stream, and even fiber optics signals if you have the option for that in the meter. Yes, let me check. So, these meters you can get in several models. Probably you know this already. There are several models available in the Ranger Neo family, and some of them you can get in different formats. So, what I want to show you first is all these different formats. The first one is the portable one, and I have one here that I want to use as an example. The portable format is a very compact, racked design with an autonomy of 5 hours, specifically designed to work outdoors under any kind of weather conditions. You can see here there are several inputs, outputs. Under this design, you can find 5 models. The Ranger Neo Lite, Ranger Neo Plus, Ranger Neo 2, 3, and 4, 5 models. From these 5 models, 4 of them, the top 4, the Ranger Neo Plus, 2, 3, and 4, you can get with an option that allows you to convert this design into a rack mount design, which is this other design that I can show you here. This is for you high. You keep all the buttons from the front panel, the screen. So this means that you can operate this rack mount format from the front panel or using the web control remotely, VIP, from a remote computer. This is a perfect match for use, for example, in SNG tracks, OB bands, etc. Then we have a third design format, which is this one that you can see here, 1U, rack mount as well. Here you lose the screen, you lose the front panel buttons, which means that you have to exclusively control it VIP using the web control interface. The difference between these, there are 2 models here with this format. the ProWatch Neo Plus and ProWatch Neo 2. These are equivalent to the Ranger Neo Plus and Ranger Neo 2 models from the portable version, with the difference that this is rack mount, as I said, 1U, and there's one more difference, which is that it features an extended storage capacity of 1 terabyte, because this format is specifically designed and meant to be used for continuous monitoring of signals. You monitor signals 24/7, continuously, for days, weeks, and you store all that data that you're measuring in this internal storage. So that's why we featured an extended storage capacity here of 1 terabyte. So 3 formats, as many as 5 models in the portable version, 4 in the rack mount 4U high version, and 2 models in the ProWatch Neo version. Now, all of these models and formats, they share all of them the same core technology. They have the same philosophy of operation. The difference comes in, depending on the model you get, you will have more or less features. But the core technology and the philosophy of how you operate the unit is the same. And this is what I want to show you now, how you use the meter. In order to do that, I will move here. I will sit down. Let me explain to you the setup that we have here. We have 2 signal feeds, one with terrestrial signals. It's a feed with terrestrial signals, another one feed with satellite signals. This is a mixture of DBBS, DBBS2 transponders coming from Hotbird, from the satellite dishes we have in the rooftop. And this is a mixture of terrestrial signals, FM, DAB, DVB-T signals, coming as well from the aerial that we have in the rooftop. So I connect the terrestrial feed to the RF input on the meter, and then what we will do, the first thing you need to do is to select in the preference menu, select which input you want to analyze. So for that we go to signal source and select RF. There are many options here depending on the input that you want to use, IP multicast, or if you want to analyze Wi-Fi or CCTV cameras, the picture from a CCTV camera, etc. In our case we will select RF. And then you need to select which band you want to analyze. If you remember, the Ranger Neo meters cover 2 different bands. A terrestrial band that goes from 5 megahertz to 1 gigabyte, to 1 gigahertz, sorry, and a satellite L band that covers from 250 megahertz up to 2.5 gigahertz. So in our case, we are analyzing a terrestrial feed, so we will select terrestrial. So we are done here. And now I already arranged a specific channel plan previously that contains only a couple of DVB-T channels that I want to analyze for this demo. So this is the channel plan, terrestrial Barcelona. I'm tuning the channels moving by channel, not by frequency. And once you select it, the unit will automatically tune one of those channels included in that channel plan. So this is a DVB-T channel. The second thing you need to know is that there are, here on the left side of the screen, you can find these 3 buttons. These are the 3 main modes of operation. In the middle, the spectrum analyzer mode. On top, measurements mode. And on the bottom, the TV mode. You will usually use the meter in this order. You will want to go first to the spectrum analyzer mode, which is where we are, tune a specific signal that you want to analyze. Once you tune it, for example, let's tune another one. Once you tune it, you will see that the meter is demodulating the channel and locking to it. These white dashes, these white dashed lines on either side of the channel means that it's locked. The meter is locked to the signal. And then immediately after, you will see a number of measurements on top of the screen. If you want to check the measurements in detail, you can go to the measurements mode. Here you see all the measurements, and once you've done here, you can move to the TV mode. here you are able to watch any service that is included in the digital terrestrial multiplex that you're demodulating or the satellite transponder that you're demodulating. Actually, if you want to choose the channel, you just go here to Tools, select Service, and you will see the list of all the services carried by that specific MUX or satellite transponder. Now, these are the basics on how to operate the meter. Then, if you want to access to the more advanced measurement tools, you will need to go back to the spectrum analyzer and press F3, where you can read Tools. And here you have a whole list of different advanced measurement tools that will allow you to take advanced measurements on satellite links, terrestrial links, cable TV signals. For example, field strength meter, transport stream analysis, transport stream recording, constellation, MER by carrier, merogram, spectrogram, network delay, echo analyzer, etc. I won't get into details in each one of them because we have already developed, we have a playlist in YouTube with as many as at least 40 videos, each one of them showing how to use each one of these individual features, each one of these individual advanced measurement tools. And we explain there in very much in detail how to use them, how to work with them, what are they for, etc. So what I want to do now is to show you in detail the two advanced measurement options that we have released recently. One is the DAB Plus Advanced Measurements option, and the second one is the Advanced FM Measurements option. So we will start by the DAB one. And to do so, I'll change to the a different channel plan that I created as well previously, called DAB Barcelona, which contains just a couple of DAB channels that we are receiving here from the rooftop. Let me choose it. The meter again is automatically tuning one of these DAB channels. Okay, you see the white dashes again. This means that we are locked to the signal. Now, if you remember, in the past, we already had a DAB option. It's what we call now the basic DAB option, and that allowed you to do three things mainly. One, you could tune the DAB signal and demodulate it. Second, you could get some measurements over that DAB channel. For example, we were providing you with the power level, carrier to noise, MER, and channel BR. And finally, we could extract some data from the ETI ensemble and show it to you in the TV mode. Now, with the new advanced DAB Plus option, we can do several more things that you will see now. First of all, let me show you the measurements mode. We are providing you with more measurements now. You get still power level, MER, carrier to noise, and the channel BR for the whole ensemble, for the whole ETI. But besides this, we calculate as well the channel BR for the MSC. The MSC is the main channel, the main service channel. This is where your digital radio services are stored within the ETI. We calculate the channel BR for the FIC, the fast information channel. This is where the metadata from the ETI is stored. Is the metadata that allows the receiver to retrieve the digital radio services. And finally, we provide you with the FIB ratio, the fast information block ratio. This is quite important. Why? Because the meaning of this FIB ratio is, the FIB ratio is the percentage of correct data that is coming from the CRC, the checksum, that is performed over the fast information channel. So this means that you should have 100% or something very close to 100%. Otherwise, it means that you have a number of errors happening in the fast information channel, which is the metadata that allows the receiver to extract the digital services. So if you have problems there, probably the receiver won't be able to extract the data to show you the services. So very important, first check the FIB ratio after the fast information channel BR, and then the BR for the main service channel and for the whole ensemble. Other tools that we are providing with the new DAB Advanced Measurements option. To show them, we will go back to a spectrum, and again, you need to go to F3 Tools. Here is where you will find all these advanced measurement tools. First, you know that DAB Plus is using DQPSK modulation, so you can check this constellation, the quality of the received symbols, by selecting constellation. So indeed, this is a DQPSK. DAB Plus as well uses OFDM as a scheme of transmission. This means that the whole bandwidth of this DAB channel is divided in a high number of narrow band subcarriers, and you can calculate the MER individually for each one of these subcarriers. If you want to do so, you need to go to Tools and check the MER by carrier. Here what you see is the span is showing you the whole bandwidth of the DAB channel, that's 1.6 megahertz. Horizontal axis, these numbers mean the number of carriers, of subcarriers within the channel. In the vertical axis, what you can see is not power level, this is MER value for each one of these carriers. As you can see, the quality of this channel is quite bad. Then, more tools. Echo analyzer. DAB and DAB Plus signals can be operated under SFN, which means that it's very handy to have a meter that can allow you to test the quality of the signal at the receiving point and see if the signal that is coming from the main path, from the main transmitter, is being interfered by echoes that come from further transmitters. The way you use the echo analyzer is the same way that you use the echo analyzer for a DVB-T, for analyzing a DVB-T or DVB-T2 signal. So you have, let me zoom in. You have, you are shown in blue the main signal coming from the main path, the main transmitter, and in white you can see echoes. Everything in the red area is echoes that are falling outside the guard interval, so very damaging for our signal. And everything that is within is inside the guard interval. For each echo you can see power level, delay, and distance. So the way you operate this tool is the same that you would use for DVB-T or T2 analysis. Besides this, you can record the ETI, the whole ensemble. You can record the in-phase and quadrature components from the received symbols. And this is saved in a WAV file, that WAV file, that can be afterwards, can be transferred to an external pen drive, and then you can open it up with a third-party software like, for example, MATLAB. And something else I want to show to you is the DAB TII information. Here what we show is two sets of data. On the top part of the screen, you can see two graphs. The one in yellow is showing you the TII information that is sent, is transmitted using null packet periods. And then in green, what you see is the PRS symbol. This is the information that the receiver is using to sync to the DAB signal. In the lower part of the screen, we provide you with the main information. This main information is an identifier that defines the country or region where the signal is being received from. And the SAP is another numerical, another identifier that defines what is the transmitter from which we are receiving the DAB signal. So a lot of advanced DAB measurement tools, very exciting. I think you will find them very helpful. Now let me move on to the FM measurement, the advanced FM measurement tools. To do so, I will just, I don't want to use this DAB terrestrial channel plan anymore, so I'll change to CCIR, and I want to tune instead of by channel by frequency. I know there's a FM radio station in 105 kilohertz. Okay, let me change the span. Okay, in just a moment it will lock to the FM carrier. We are locked already. If you remember, we have always been compatible with FM signal. So meaning that we can tune the FM carrier and demodulate the carrier and provide you with the signal level. And you can listen to the FM service, the FM radio station. But now with this new advanced FM option, we can do a number of new things. The first one I want to show you is if we go to the measurement mode, here besides the signal level for that carrier, now you can see the signal level for the demodulated multiplex, FM multiplex, the MPX, and you can see as well the deviation, the FM deviation of the whole carrier, of the left plus right subcarrier, the left minus right subcarrier, the left and right subcarrier separately, the MPX, the stereo pilot, and the RDS subcarrier. Now we will see this more graphically because there's another option that allows you to see the FM MPX signal, demodulated signal. Here, FM MPX spectrum is called the tool. And what you can see here is the spectrum trace of this whole MPX, which is formed by a number of subcarriers. The first one that you can see here on the left, this first one is the left plus right subcarrier. Then you see a very narrow band peak. This is a stereo pilot, following by the L minus right subcarrier. Then this little mountain with two peaks, this is the RDS subcarrier. So you can see everything here very much in detail. There can be even more subcarriers after the RDS. I won't get into detail. I won't get into details with that. But so you have an idea, the MPX bandwidth can go as far as 70, 75 kilohertz. So the last tool I want to show you is, let's go back to Spectrum, now Tools, the FM histogram. And I'll explain you what we are showing to you here. The idea is that what we show you here is the MPX FM deviation. But what is the distribution of values that this FM MPX deviation is presenting? So what we do is, there are two ways of calculating this. The first way is we set up this max 50 milliseconds. This is the first way. Both ways are standardized. So these are measurements that are taken according to the standard from the ITU. In the first way, max 50 milliseconds, what we do is we take several readings over a period of 50 milliseconds, several readings of the MPX FM deviation. And when this 50 milliseconds period finishes, we keep the maximum one, and we do it again. So we do it consecutively for several periods of 50 milliseconds, and we keep the maximum readings. And with all those readings that we keep, we plot these graphs. What you see in the yellow graph is the distribution of MPX FM deviation values that we took the readings, how they distribute. So for example, now what we will do is we will set up a threshold. We will say, okay, it's very common, for example, that you don't want your MPX FM deviation to be higher than 75 kilohertz. So I'll choose 75 kilohertz here, and the meter is showing me on the yellow screen, on the yellow plot, sorry, how many samples show an MPX deviation of 75 kilohertz. 2.3% of them have a MPX FM deviation exactly the same as 75 kilohertz. While the red graph is telling me that from all the samples that I took about the MPX deviation, how many of them have an MPX deviation of 75 kilohertz or higher? So 76%, 77 almost percent of the samples that I took have an MPX FM deviation value of 75 kilohertz or higher. And as I told you, there are two ways of calculating this. This maximum 50 milliseconds or all samples. In the all samples, everything I told you has the same meaning. The difference is that instead of taking the maximum reading from each 50 milliseconds period, I use all the readings. So this is the new tools that you have to test FM carriers. And now, if it's okay with you, we can. I would like to show you, give you a quick tour on the web control tool. I told you that all the Ranger Neos, but the Ranger Neo Lite, all of them feature the web control, the internal web server that allows you to control the meter remotely from a remote PC, BIP. So let me show you that. Now we will switch to the video coming from the HDMI output of my computer. Change this back to the channel. Okay. So as you can see, I have in this case both. Yeah, I have. Okay, so I have both the meter and the computer in the same network. I open my browser, I input the IP address of the meter. So what you see here now is already the presentation screen of the web server. I'll input the password. Okay, and now here in the web server, what you can see is 6 different areas on the left. I will go very quickly over them, or some of them, because we already have these tutorial videos that I told you about that explain you in depth each one of the sections. The measurements and spectrum area, the first area, is some kind of mixture between the spectrum mode and the measurements mode, all together in one screen. So what you see here is on the left side, the spectrum of the analyzer, and for the signal that you are tuning, you can see on the right all the measurements. Again, you can select any channel plan that you want to work with. You can tune by channel or by frequency. You can change the reference level, the span, etc. The second area is would be something equivalent to the TV mode. And here you see the TV picture of the service that you select from the signal that you're demodulating. You can even record from here either that single service or the whole transport stream. And on the left side, you see several metadata that comes from the PSI side tables regarding the service, the video, and the audio. The third area is quite interesting, is what we call the Ranger Neo console, and this allows you to completely have full control over the meter. That means having full control over every single feature that you can find in the meter remotely. In order to do so, what we do is we recreate the front panel of the meter in the screen. We press this button, Start Emulation, and just by pressing with our mouse the different buttons on the front panel, we will be able to control the meter, and the meter will be streaming back the picture on the screen to us. So from here, you can do anything that you would do operating the meter manually. You can just go to Tools, and for these MOOCs, just check, for example, the constellation. Let me see if I can find it. Well, MER by carrier. Okay, so you can just access to any feature on the meter through the Ranger Neo console. Let's stop this and move to the fourth area. The fourth area is specifically designed to monitor 24/7 channels from a channel plan that you have created previously. For the purpose of this demo, what I did is I already created a channel plan, and I created a monitoring task. So in order to show you how it looks once you have already created the monitoring task. Is this one, monitoring terrestrial Barcelona. This channel plan contains 3 channels, 3 DVB-T channels, but you could do it with any kind of channel plan containing cable TV channels or satellite channels, doesn't matter. How you work with this is exactly the same. In this case, there are 3 channels, DVB-T, and for each one of them, what I will do is define what are the thresholds for each one of the measurements, power level, carrier to noise, MER, etc. The thresholds that will make the alarms go off. So I can set up a threshold for a pre-alarm and a threshold for a final alarm for each one of the measurements. And these thresholds can be defined differently for each channel. So this is channel 1, but if I go to channel 2, you can see that there are other thresholds. Obviously, for example, the minimum MER requirements that you will have in a QPSK modulated signal will be different than in a 64 QAM signal. So this means that you will need to use different thresholds for each channel. This is already set up here, and what we do now is we define what are the emails of the people that we want to get notified when an alarm goes off. And once this is done, we can just launch the monitoring. Okay, save the data. Okay. Okay, the screen, once we launch the monitoring task, the screen will switch to a different kind of a screen that shows you on the top part of the screen all the different channels that we keep tuning and measuring. So now it already measured the 3 of them, and it's starting in loop. It's continuing in loop. So it's sequentially tuning each one of them, taking all the measurements, and when it's over, it starts again from the first one, in loop. And on the lower part of the screen, what you can see is all the different measurements that are being stored for each one of these channels in our channel plan, and on the right side, all the alarms that already went off. So while this is running, you don't need to stop it while this is running, and this can run for days, even weeks, 24/7 without a stop. While this is running, we can move to the next area, and this is the monitoring reporting area. Here we can extract reports of what has happened so far. I'll show you an example. For example, you can extract data for all the channel plans or just one of them, let's say all. We can extract the information of all the measurements or just one of them, let's say all again. From which day to which day? Let's say that we want to know what happened during last night. So I will select today is 11th. 11th from 12:45 until 11th, whatever. And then you can select whether you want to extract only the measurement information or the alarm information or both. So I press on done, and now the meter will extract all this information, create the report, and you can download separately in CSV format the report for the measurements and for the alarms, so that you can further process it with whatever editing tool you want to use. So the final area, I will stop the monitoring task. The final area that I want to show you, this is new as well, is the installations management area. This is made of 2 different sections. One is the file manager. From here you can navigate through the system of folders and files within the meter, and, for example, download any kind of the resource or any kind of resource that is stored in the meter, like a transport stream file that you have recorded, a screen capture, a data logger, whatever it is, you can download to the PC from this area. Or you can upload data into the meter as well. And the second section is the channel plan creation area. This allows you to either create new channel plans remotely or edit previously created channel plans, and all of it you can do from this area. So I thought you found helpful all of this information, and just let me show you, well, let's see the different measurements that we are receiving from WhatsApp and YouTube.
Yes, we have received, Carlos, a few questions, and I think we have time for some of them. Yes, we have some time.
Okay.
The first question, I guess, is about the remote control,
Okay.
because it says, do we need any PC software to run the monitoring application?
Not at all. No.
Does it have a separate cost? So I guess.
No. The web control feature is something that is included in the meter by default. Remember, in the Ranger Neo 4, 3, 2, Plus, but not in the Lite. And you don't need to use any external or third-party software or anything. Just go to your browser, input the IP address of the meter, and as long as there is IP visibility between the meter and the PC, so as long as you have set up the network correctly so that they can see each other, you will be seeing the web server opening up in the browser, the internet browser, and you will be able to operate the meter remotely.
There is another question here. Someone is asking which measurements can you do on the transfer stream?
Okay. Let me see. Let's switch over to the HDMI signal coming from the meter. So, yes. Okay, for example, I'm now already locked. I'm tuning and I'm demodulating a DVB-T signal. Okay. Once you're locked to any kind of digital signal like DVB-T, DVB-T2, C2, SS2, S2 multistream, you can go to Tools, and in Tools, you have an option here called TS Analyzer. And this transport stream analyzing option gives you three measurement tools. The first one is the tables analysis. If we choose this option, the meter what will do now is to read all the information from the PSISI tables, and then it will let you navigate through the PSISI tables in tree structure. Let's see. This is DAB, sorry. This is not DVB-T. Let me see. Is it? Okay, now we are locked. Let's go to tables. Now it's reading the PSISI tables. This will take just a few seconds. How long it takes, usually it depends on how many services are within the transport stream. So for example, in satellite transponders, it can take a while. Let me choose a different thing happening. Let me just tune by frequency. See if this makes any difference. Okay. Okay, we are locked. Okay. Okay. So now it's reading the different the PAT, the PMTs for each one of the services, etc. It will just take some seconds. Almost done.
Also, Carlos, maybe it's worth mentioning that we have, as you said before, dedicated videos for.
Yes,
for
yes.
this.
There is actually there's a video, 5 minutes video, explaining in detail how to use this transport stream analysis tool. So now it already read all the PSI side tables, and now you can navigate through them in tree structure and see all the different fields that are included in the PSI side tables. So this is one tool. Second tool is the bitrate analyzer. Here what you see is all the different services that are included in that MOOCs. And for each one of them, you can see the percentage contribution in bitrate to the total of the transport stream. You can see it here, and you can see it in the pie chart. And then for the service that you are selecting, you will see this bar in the low part of the screen that shows you what is the percentage contribution of the video, the audio, and the data for that service, and what is the nominal value of bitrate for video, audio, and data for that service that we have selected. And here you see the total bitrate of the service, total bitrate of the transport stream, and the netto bitrate of the transport stream, which is the total bitrate of the transport stream minus the bitrate of the PSI side tables. And finally, you have an alarm analysis. The alarm analyzer allows you to monitor all the different points that should be monitored at transport stream layer according to the TR 101.290 norm. You can enter into each one of these alarms and see the description of what you're actually monitoring and whether there was an alarm going off or not. In this case, you can see them in red.
I think if someone is interested to dig a little bit farther into that, there is a dedicated video on our YouTube channel. Here is another question. Is satellite band included or is that an option?
Satellite band?
Band, yes.
No, in all Ranger Neos include terrestrial band analysis, 5 megahertz to 1 giga, satellite band analysis, satellite L band, meaning analysis of satellite signals after LNB down conversion in the band from 250 to 2.5 gigas. And all the Neos include this, and all the Neos include compatibility with T, T2, S, S2, S2 multi-stream, C and C2 signals, all of them. More questions?
There are more questions, but I think we are running out of time at the moment.
So let's do something. Let's answer all those questions during the following 2 days. Let's continue now because we have another session now for our Spanish-speaking friends. So
yes, I think we need to leave it here. Hope you enjoy the session.
Yes.
And well, we hope to see you soon somewhere.
Yes.
In one of the upcoming shows.
If they let us, we will be there.
Okay.
Thank you. Take care. Bye-bye.